Record, and we're off. Tuesday's test on stoichiometry, we're looking at our first objective, number 1, where we are interpreting balanced equations 4 different ways. The first skill, of course, is to write the balanced equation. Then we'll look at it in terms of particles, moles, mass, and volume. The big trick there is if it's allowed. Reading through the first question, it says we're to write the balanced equation for the formation of gaseous dichlorine pentoxide from its elements. And we're including what we call the adjective, which are the states of matter. The formation of dichlorine means to point at it. So you'll see me start with the product arrow. Dichlorine pentoxide says we're forming a molecule. Let the prefixes guide your product. Dichlorine, Cl2, pentaoxide is O5. It tells me that it's gaseous, so I'll put the little G sign there that we know it's in the gaseous phase. The elements that it's made up of are chlorine, who belongs to the diatomic molecular Lucky 7 club, and so does oxygen, so it's also written as O2. Chlorine and oxygen, both in nature, are gases at room temperature, so their adjectives are also little g's. Chlorine, Cl2, plus oxygen, O2, creates Cl2O5. The last thing we'll need to do is to balance. The chlorines are looking good. It's the oxygens that aren't behaving. I have 5 on the right side, but 2 on the left. We'll need to turn them both into 10s. So I'll double the product, come back and place a 5 in front of the oxygen. By doubling the product, I'll need to come back and also double the amount of chlorine. A 2 to 5 to 2 stoichiometric ratio. In our second question, it's asking us to interpret in terms of representative particles. The term representative particles is a general name for anything that could be an atom, if I see just a symbol by itself. Could be a molecule, if they're made up of all nonmetals, in which this is the case. Or the other choice of vocabulary is a formula unit, if we're considering charges as we write out our product. In this particular example, these are all nonmetals, so we have one word that will fit them all, and they will be molecules. So if I'm to interpret this in terms of particles, molecule will be my selected choice. I'm going to write 2 molecules of our chlorine, and it's okay to just put the symbol down, Cl2. We'll react with 5 molecules of the oxygen. That would be written as O2. And it's going to form 2 molecules of Cl2O5, where the coefficients can stand directly for the number of particles. Coefficients can stand also directly for the number of mole units as well. So everywhere where we wrote molecule for number 2, we're now going to change that to moles for number 3 and just rewrite the sentence. We'll have 2 moles of chlorine reacting with 5 moles of oxygen to form 2 moles of dichlorine pentoxide. In our next interpretation, we're asked to talk in terms of mass, gram units. And we remember it's not okay to let coefficients stand directly for the number of grams. It is not okay to say 2 grams plus 5 grams makes 2 grams. It just doesn't work that way. So we have to use the molar mass to convert. The molar mass times our coefficient, which stands for the number of moles, will tell us how many grams we have of reactants and products. So when I'm thinking about interpreting this, I need to do a little molar mass work. Chlorine, who has a molar mass of 35.5, there's 2 of those. So the molar mass of Cl2 is 71. I take 71 times the coefficient of 2, and that tells me I have 142 grams of the molecule chlorine. That will react with the molar mass of O2 is 16 times 2, gives me 32, and I multiply that by the coefficient of 5. I have 160 grams of the oxygen. That will produce 2 moles worth of Cl2O5. So I'll take chlorine, 35.5 times 2, since there's 2 of them in its formula, plus 16 times 5 for the molar mass of Cl2O5, I found 151. Then I use the coefficients. I go times 2. The total mass, 2 times that formula weight of Cl2O5, is to be 302 grams of the molecule, dichlorine pentoxide. It's always good advice to check, because there is such a thing as the law of conservation of mass, that the reactants must do indeed equal the product, so let's check that. 142 plus 160 does indeed equal 302, and that's what we found for the product. When we interpret in terms of volume, we can only do so if they're all gases, and this is an example where that is true. If you see any other adjective, solid, aqueous, liquid, don't write for it, but in this example we can. We use something called the molar volume, which is 22.4 times the coefficient. Coefficients stand for mole number, so we'll take the moles times molar volume to come up with the liters. The coefficient in front of our chlorine is 2, so 2 times 22.4 would show me 44.8 liters of chlorine, reacting with 5 times 22.4, 112 liters of oxygen. And that recombines to form 2 times 22.4, which is 44.8 liters of our product, Cl2O5. There is no such thing as the law of conservation of volume, so don't let that upset you that the liters equal the left and the right. Coefficient times molar volume is how I would calculate for the volume of each reactant and product. So if yours matches this, you can give yourself an A+. In a moment we'll flip to our second objective. I'll shut off the recording